Alright guys, my name is Jason and I'm going to teach you guys how to solve story problems using a table. Tables lend themselves really well to certain story problems, and typically mixture problems are the best. But the greatest thing about using a table when dealing with a story problem is the fact that you can keep yourself really, really organized. And in this case, a movie theater has sold 548 movie tickets and has made $2,460. Children's tickets cost $2.50, and adult tickets cost $5. How many children's tickets were sold? So this is a classic mixture problem. We're mixing children's tickets with adult tickets. And so I create a table, and of course, this is what you guys would be doing on your paper. You just create a table. And this square here is not really used, so I grayed it out. But this side, the left-hand side, is always what we're talking about. Like, who are we comparing? It could be factories, like factory A and factory B. It could be raisins and nuts if we're making like some kind of trail mix. It could be different types of coffee, if we're mixing up coffee. And in this case, we have adults and children, right? So great. Now, on the top row, it's always what's happening to these guys, or what are they doing. And in this case, the information that we have is movie tickets. So I'm going to write up here the number of movie tickets. There we go. So that's the number of movie tickets sold. And of course, what else do we know in our problem? We have the cost per the ticket. So let's do cost per ticket. Great. I really like to reserve these two corners as totals. And total. Because it kind of just tells us what overall is happening. So now we've created our table, and we have our nice grid layout, so we're able to kind of look at things and see if we have any information we can just add to these boxes. So we look back at our problem, and we see that we have a total number of movie tickets. So that would be the number of tickets sold and a total. So that goes in this cell here. So 548. So what else have they given us? They've given us this dollar value, right? That is a total dollar value. And so that would be 2,000. 460. Great. Now, what else do we know? We know the children's tickets cost $2.50. And we know that the adult tickets cost $5. All right. Do we have any other information? Looks like we've actually covered all of it in here, so we don't really have anything more to add. Now, what could this be? We have these blank spots that must have something in there, or we would have trouble solving the problem, right? So you see the number of movie tickets sold and the number for adults. That's this box. Number of movie tickets sold for adults would be here. Number of movie tickets sold for children would be here. So gosh, that's kind of our unknown, right? That's what we're trying to solve. How many children's tickets were sold would be this box. So, what do? It sounds like we have a variable, right? So we need to assign a variable to one of these boxes, and we can actually choose either one of them. We're not going to break anything by putting an X in the adults. We could totally do that, and we'd be justified. But the thing is, we are talking about the children's tickets, so although we would still end up getting the right answer, and I can prove that to you if need be. You know what? I'll just prove it now. Let's go ahead and say that we started with adults as our X. Now, it makes more sense to put the X here, but we could put the X up here. And so that would mean that how is this related to adults, right? How is this box here related to the our variable? Well, we know that we have a total number of tickets. We have 548 tickets sold, right? So if we were to subtract the number of adult tickets sold from this total value, we would end up with the children's tickets, right? So let's do that. So 548 minus x. Okay. Let's do that again. 548 minus x. Cool. All right. So this means that we're solving for the adults in this case, which is fine, but we can figure out what the children did later. Now, it's cost per ticket, and so it's the number of tickets sold, and it's how much it costs per every single ticket. So it's per tells us it's a multiplication problem, right? It's per ticket. It's how many tickets sold, how many tickets we had for the adults, and then every single adult that we have is going to be charged $5. So what we're going to do is for our total box, we're going to multiply this thing across. So this is going to be $5 times x. And I like to put things in parentheses because we're combining them. In this case, the parentheses are going to end up going away. It's just going to become $5 x, but that's just the way I always do it. I like to keep everything separate in the beginning. So, the children, it's going to work the same way. We have a certain amount of children, right? It's the difference between the total number of tickets sold and the adults, and we are going to multiply it by $2.50. So I'm going to put $2.50, and I'm going to multiply it using my parentheses because that makes life so much better, and you'll see why in just a moment. Great. There we go. All right. So what do we have here? We are trying to add up. We have this total, right? This $2,460, and the way we get that is we take the price that was paid by the adults and the price that was paid by the children. Heck, we can even write this as total price if you want it, you know, or cost or whatever you think you want to make it easier for you to think of. This is this plus this would equal that, right? It's the adults and the children. So let's see, the adults plus the children equals this total value, this 2,460 that they gave us, right? But we know what the adult price is, so we can substitute that in. So it is $5 x plus the children's price of $2.50 times 548 minus x equals, and that's going to equal this grand total of $2,460. Great. So we have our formula now, and so we're going to solve for x. So let's do that. This is kind of posing a problem for us. We would like to distribute, so this is going to multiply this way and then that way. And so let's pull up my trusty calculator and see what $2.50 times 548 is. 250 times 548. Okay, so that is going to be $1,370. All right, so here's what we do. We didn't do anything with this, so I'm just going to bring it straight down. $5 x plus, okay, we're distributing this into here first, and that was $1,370. And then we're going to multiply this in here, and this is going to become minus $2.50 x. Now, this is a part where a lot of students kind of get worried because we're ending up with some negatives, but it all works out in this case. In fact, if we had done it the other way with having the children as our x value and the adults as this 548 minus x, we would have found that this value here would have actually been a negative. So there's some crazy things that happen, and this would have been a bigger number, and they all would still work out in the same way. So I'll let you guys test that on your own. You guys can set up this problem the exact same way. Just do x for the children, and then 548 minus x for the adults, and see if you get the same answer, which you should, right? Alright, anyhow, so we're going to continue on solving our problem. We're going to combine our x values, and so this is going to become $2.50, because $5 minus $2.50 is $2.50, and we're going to keep our x with it. I started using small x's, so we're just going to keep going with that. And then 13 equals, and notice I'm not doing anything with the numbers. Like, I didn't do anything with this number, so I just brought it right back down. We're trying to stay as organized as possible. Brought this one down. Now I'm going to bring this to the other side, and so that means I'm going to subtract 1,370 from 2,460, and I'm just going to do that on my calculator over here. 60, and I'm going to get 1,090, and so I'm just going to bring this down again. $2.50 x. Oh my. Alright, equals 1,090. Alright, and now I'm going to divide this 1,090 by $2.50, right? So I can get this x all by itself, because that's what we want. And so we have 1,090 divided by $2.50. 436. Okay. So that means 400. Alright, now we always need to check to see if we've solved the problem. X is 436 tickets, right? So, oh, look at this. We are looking for children's tickets, but we found the adults' tickets, because the adult tickets are what the X is. So if I were to want to find what the children's tickets are, I would have to say 548 minus this 436. $548 minus 436. Okay. And I'm going to cheat. You guys don't get to use Excel when you're working on this stuff most likely, but I'm going to put a little equal sign here and just bam, there it is. So that we know that now that the children, because it was 548 minus the 436, 112 tickets were sold for the children. And that is what we were trying to solve. So you always want to restate the problem. So I'd say how many children's tickets were sold, right? And the answer is 112 tickets. And there we go. So as you can see, using a table is a really nice way of solving these problems. It's just keeps you really organized. You know exactly what you're getting. You can easily add these guys together to get this. I mean, it's just, everything works out so nicely. And it works very well for many different mixture problems. So give it a shot, and thank you so much for watching.